today I would like to take you through properties of limits of a function. Properties of limits of a function helps us to evaluate the limits and it helps us to understand how how, how to evaluate different operations as far as limits is concerned. So properties of limits apply when these properties of limits apply when the individual limits exist. For example, if let's say let f of x no let the limit as x approaches to a of the function f of x be equals to L, and limits as x approaches to a of a function g of x uh, b equals to m. If you're given limits like this, then these properties of limits, here are some of the properties of limits. The first property is the sum rule. The first property is the sum rule. If you're given limits of a function as x approaches to a of a function, f of x plus g of x. Limits of a function f of x plus g of x, which is equals to limits as x approaches to a of a function f of x plus limits as x approaches to a of a function g of x. We are given limit of f of x of a function f of x as x approaches to a is L. Here we get the L plus limits of a function as x approaches to a of a function g of x b equals to m. This satisfies the sum rule of what of properties of function. The second property is the difference rule. The difference rule. The difference rule. The difference rule, or the difference property of limits of a function. How can we get the difference property of the difference rule of properties of what of a function? Here is the difference rule of property of function. If you're given limits of a function as x approaches to a of a function f of x minus g of x, with f of x, the limits of a function as x approaches to a of a function g of x is L, minus limits as x approaches to a of a function g of x is m minus m. That satisfies the difference rule as the second property of limits of a function. Then the third one is the constant multiple rule. Constant multiple rule. This is the third property of limits of a function. A constant multiple rule states that limits as x approaches to a of a function c f of x. C f of x is a constant multiplying the function of limits as x approaches to the of a function f of x. This one can be written as c, which is a constant, multiplied by limits as x approaches to a of a function f of x. Therefore, which is equals to c multiplied by the limit of a function as x approaches to a of a function f of x is given as L multiplied by L. That is it. This satisfies the constant multiple rule as a third property of limits of a function. Then we have the first property is the product rule as the first property. The first property of limits of a function is in the product. We got it from the product rule. The product rule says that limits as x approaches to a of a function f of x multiplied by limits the product rule says that limits as x approaches to a of a function f of x multiplied by the function g of x. This one, you are given the function f of x, you are given as a L, which is equal to the function f of x is L. Then the function g of x, the limit as x approaches to a of a function g of x is M. See, this is equal to, now implying that the function limits as x approaches to a of a function f of x multiplied by limits as x approaches to a of a function g of a will be equals to L multiplied by M. Then we have the fifth property. The fifth property is the quotient. The quotient property or quotient rule. Here in the quotient rule, it says limits or as x approaches to a of a function g of x divided by f of x. That is the quotient rule, which is the fifth property of limits of a function. The limits as x approaches to a of a function g of x is given as a M. Then limits of a function, limits as x approaches to a of a function g f of x is given as a L. Provided that L is not equals to 0. It satisfies the fifth property of limits of a function called the quotient rule. Then we have the other rules like the power rule. The root rule, limits of a constant of a function, then limits of identity of a function, then the composition or continuity rule. Therefore, I would like to take you through. I will urge you to go and research on it. The power rule, then the root rule. Therefore, I want to give you the composition or the continuity rule. The composition or the continuity rule. What does it say? We have other properties of function. We have the power rule. We have the seventh one. We have the root rule. The root rule. Then we have limits. We have the composition or continuity rule. Yeah, composition. The composition or continuity rule. If you're given a function, if this is the eighth property of limits, the composition or continuity rule. If you're given limits as x approaches to a of a function f of x b equals to x, b equals to L, and G is continuous, and G is continuous at L, and G is continuous at L. Then limits as the x approaches to A of a function G of multiplied by a function f of x is given as a G multiplied by the limits as the x approaches to A of a function f of x, which is equals to G multiplied by the value of the limits of as x approaches to A of a function f of L is L. This gives you GL. Thank you so much. I therefore encourage you to go and carry more research on it, on your Google or YouTube to discover more about limits of a function. Thank you so much. Have a nice day.